Good morning, my YouTube viewers. It's Crystal here. What I wanted to talk about this morning was Monte Carlo simulations or Monte Carlo approximations in Excel. And the reason why is because I want to do a lot of things in Excel because basically I'm paying for Excel, so I may as well use it since I'm paying for it. And Monte Carlo is a type of Bayesian statistics. So we're going to cover 3 Monte Carlo approximations. So the first Monte Carlo approximation that we're going to cover is going to be pi, how to calculate pi. So we've got x, you've got your x variable and your y variable, your distance, your inside circle, and your pi approximation. So for the x variable, you have rand up for about 250 rows of data. You're creating a random number between 0 and 1. For your y variable, again, you have rand, which is a random number between 0 and 1. Your distance is the square root of the square of a2 squared plus b2 squared, and that goes all the way down to the 250 rows of data. So that's your distance. And then on your inside circle, if c2 is less than or equal to 1, then you get a 1. Otherwise, you get a 0. So, and then you have your pi approximations. It's the sum of D2 to D250 divided by count of D2 to D250 times 4. So that's going to give you an approximation of pi. And what we have in this instance, we have 3.13, which is less than 3.14. So you are approximating pi when you do that. So that is our first Monte Carlo simulation. Now what we're going to do is we're going to do a Monte Carlo approximation with the gamma distribution. So you've got your random uniform, which is 0 to 1. You've got your gamma sample. You've got your alpha, your beta, your mean, and your variance. So your alpha is 2 and your beta is 1 divided by 3, which is 0.33333. So on the row A1, you have a random number, which is 0 to 1. And then what you do is you copy that formula down to, I think it's about 100. Column B, you've got the gamma.inv function, which is the inverse of the gamma function, and it's on A2, and it's going to use your alpha and your beta. So your alpha is E1 and your beta is E2, and it gives you a 0.85542396, and you're going to copy that down to, and I think it's 100 rows. You have your mean, which is the average of B2 to B101, and which is 0.6621, and then you've got your variance, which is the variance of B2 to B101, which is 0.18752. So what you're doing is you are approximating what the distribution is, approximating the mean and the variance of the distribution. And then what we did was we created a histogram. And when we created the histogram, you can see that this is the gamma distribution because it is right skewed. So a gamma distribution is right skewed. So we recreated what we got, the gamma sample, and it's a gamma distribution, so that's what we wanted. The next one is beta distribution. And beta distribution is going to be identical to gamma distribution, except for instead of using gamma, we're going to use beta. And then so basically what happens is the random for the first 100 rows, you're going to have a random number between 0 and 1. And then for the beta, it's going to be beta I and V, A2, E1, and E2. E1 is your alpha and E2 is your beta. And you're going to copy that down 100 rows. We're going to get the mean is is the average of B2 to B101, which is the average of giving you an outcome of 0.49, and then you get the variance between B2 and B101, which is the outcome of 0.05, which is your variance. So you can see that this looks sort of like a normal distribution. It looks similar to a normal distribution because you have the middle columns of data. The middle columns of data are larger than the side columns of data. So it's trying to be a normal distribution. And then if you put a KDE plot on it, it probably would actually be a normal distribution. So what I did was I set the alpha and the beta up to both of them to be 2 to give you a normal distribution. So that's it. That's how you do it. And basically, I did it in R, and because I'm taking a course on Bayesian statistics, so we know Monte Carlo is to do with Bayesian statistics. So I did it in R. I don't think I made a video in R because the instructor just kept moving around back and forth, not the way I would do it. But then I tried to translate the R code into Python, and it was a little bit more difficult for me to do that. The reason why is because I'm under serious time constraints. So I asked my good friend Copilot to help me translate from R to Python. So I did it in Python, so you may have seen my videos on Python. And then I wanted to do it in Excel, and the reason why is because I'm paying for Excel, so I may as well use Excel. And so my good friend Copilot showed me how to do it in Excel as well. So that's it for this video. We covered Monte Carlo approximations, we covered pi, we covered gamma distribution, and we covered beta distribution. So that's it for this particular video. If you like my video, please like and subscribe. And thank you so much for watching my video. I will be making another video soon about technical subjects, and look forward to you watching it.